Okay, hi guys. Here we are on week 9, task 3. So I'm going to go over how to do mass-to-mass calculations in stoichiometry. So it's kind of a longer, lots of bunk beds. So there's usually 3 or 4 bunk beds in this, but don't worry, you've seen all of this math before, so I'm just going to take you through it. So here's the PowerPoint. It says, after today, you're going to calculate the number of grams produced or reacted for a substance in a given chemical equation. So these are the steps that you need to convert for these calculations. You're going to convert grams to moles using the molar mass of the known. Then you're going to convert moles to moles using the balanced equation that we learned yesterday. And then you're going to go from moles to grams using the molar mass of the unknown. So I'm going to show you a bunch of examples of these, and this will make sense. These 3 steps right here that you can see are in the slides. So if you need to write those down in your notes so you know the 3 steps, that's great. They are in the slide for this week. This is an example. I'm going to write down the question. I'm going to do it here with you so you can see it a little better. So it says, what mass of silver chloride will react with 15 grams of aluminum? Okay. So let's look at this. We were given some information, not a ton, but let's see what we can do with it. What mass of silver chloride will react with 15 grams of aluminum? Okay, let's figure this out. Let's start with our equation. So, what does this chemical equation even look like? We can write it out in words first if we want. I'm not sure if they even gave it to you in the question. I don't believe they did. So let's do it ourselves. What's the mass? What mass of silver chloride? So we have silver chloride. So we need a little scrap down here. Silver's Ag. Grab your periodic table. Find out what his charge is. I think he's a +1. Yeah, I'm right. +1. Chloride is Cl -1. Crisscross. This is silver chloride. AgCl. So we have silver chloride. What mass of silver, we'll worry about the masses later, of silver chloride will react with 15 grams of aluminum? So we've got aluminum. I'll go this way just to have some space. Aluminum is reacting with silver chloride. Well, I got to predict these products. Well, I know that aluminum is a metal. I know silver is a metal. So this guy's coming in here. This guy's getting a boot. So this is a single replacement. Okay, if I want to do the words up here, I could say aluminum plus silver chloride yields aluminum chloride plus who got the boot? Silver. So aluminum plus silver chloride yields aluminum chloride. Well, what does that look like down here? We got to get aluminum, right? Go look him up. Right here, he's a +3. Chloride, you just already looked him up. He's a -1. Crisscross, AlCl3. So I get aluminum chloride, AlCl3, plus silver gets left alone, Ag. When elements are alone, I double check my list. Are they on my Super 7? No, they're not. No aluminum, no silver. So those guys aren't here, so we don't have to worry about that. Put the blanks out front. Now we have to balance this because that's part of how we're going to get enough information to solve this question. So I've got an aluminum. Here's my middle line. I've got aluminum, aluminum. I got 1 silver, 1 silver. I've got 3 chloride, so if I put 3 here, then I got to put 3 in front of my silver, and I'm balanced. Okay. With my balanced equation now, I can start my little bunk bed situation. So I'm just going to grab paper from under here. And I'm just going to cover up that scrap so that I have a bit more of a page because we don't need that scrap from before. All right, so let's our known. I'm just going to move down a bit. Our known is what mass of silver chloride will react with 15 grams of aluminum? So they gave me that. 15 grams of aluminum. That's my known. What's my unknown? What mass of silver chloride? So it's asking for mass in grams. It's always in grams of silver chloride. AgCl. Silver chloride. You can write silver chloride if you want. Doesn't matter. So this is my known and this is my unknown. All right, what am I going to do with that? Let's slide this up a smidge so I've got a bit more space working here. Okay, what do? Well, over here in my problem, it says convert the grams to moles using the molar mass of the known. That's my first step. All right, I got to go grams to moles. So my first step is grams to moles of my known. Okay, so I'm going to do the same thing I always do. And I'm going to take my known and put it over 1. 15 grams of aluminum over 1. That's how we're going to start. That's how we always start. So that's not scary or a problem. So now I need to know how to get from grams of aluminum to moles of aluminum. Well, we go right back to our original cheat sheet where it says the molar mass of a compound in grams from the periodic table is equal to 1 mole of that compound. That's on this original sheet that we did these conversion factors. Molar mass of a compound in grams. Okay, so if I want to build a bunk like this, I'm going to put grams on the bottom. Grams of aluminum are going to go on the bottom because I'm trying to get rid of grams of aluminum. Well, just go find out what the grams of aluminum are from the periodic table. Grams of aluminum, I can see right there, is 26.98. So 26.98 grams of aluminum is 1 mole of aluminum. This relationship, this conversion factor, is this number 1 that you've done before. You've done this one 100 times. If I just said to stop here, convert grams to moles for aluminum, you'd be like, oh, that was easy. I didn't even have to add anything up for this compound. I just had to find it on the periodic table. I've now changed from grams to moles. The tricky part about this is our unknown is grams of something completely different. So that's where it gets a little bit, I don't want to say harder, but it's a little different. So I got to build a second bunk. Or you can do those other little multiplication that you like. So right now I get to cancel out grams of aluminum because there's 1 on the top and 1 on the bottom. So that's awesome. I'm left with moles of aluminum. How can I get from aluminum to silver chloride? This is what you learned yesterday. You go from moles to moles using a balanced equation. So I want moles of aluminum on the bottom because I want to cancel it. And I want moles of silver chloride on the top because I'm trying to get to silver chloride. So how do I know what to put here? I get to use my balanced equation. How many moles of aluminum are in this balanced equation? Well, you guys know if it's a blank, you should know it's a 1. Here we are right here, 1 mole of aluminum. So I get to put 1 on the bottom. Is equal to how many moles of silver chloride? Well, I get to look at this balanced equation. Boom, there it is. 3. Awesome. So now I get to cancel moles of aluminum. Moles of aluminum get to go away. So right now I'm left with moles of silver chloride. But what did my question ask me for? It asked me for grams of silver chloride. So what's a conversion factor between grams and moles? It's the same one. It's the first one. Molar mass of a compound in grams from the periodic table is 1 mole of that compound. Here we put grams on the bottom because we're trying to get rid of grams. But right now I'm putting moles on the bottom because I'm trying to get rid of moles. Moles of silver chloride. So if I put 1 mole of silver chloride on the bottom, and I put grams of silver chloride on the top, that's the units I want. I just need a little sidebar here. I need a little scrap work. I need to say, what's the mass of silver chloride? Well, I gotta go look. Silver, 107.87. Chloride is 35.45. Add those up. Just grab my calculator here. So 107.87 plus 35.45 gives me 143.32. That's the mass, the molar mass of silver chloride, because all we did was find the numbers from the periodic table. Well, the molar mass of a compound in grams from the periodic table is equal to 1 mole of that compound. That's what it has always said on our sheet. So we get to put the 143.32 grams in here, and it equals 1 mole of that. That's a conversion factor we've used many times. It's just using it in a different way. So now my moles of silver chloride get to go away. What's the only unit left? Grams of silver chloride. What did my question ask me for? Grams of silver chloride. Awesome. Now I just got to do math. So how I do these questions is I will go 15 times 1, which I won't do, times 3 equals times 143.32 equals, I'm not dividing by 1 because I don't need to, divided by 26.98 equals 239.04 grams of silver chloride. That, my friends, is our answer. And that's what's on the sheet. Okay? So I realized that I've now gotten you to use words. First, I got you to make an equation. You have to get that right. You have to crisscross right. You have to do everything. Then you have to balance it. Then you have to go find the molar mass of things. Then you have to balance the equation and use the mole to mole ratio. Basically, at the end of this chemistry class, I can ask you one question and I can almost make you do everything I've taught you all year. So that is the beauty of chemistry. It builds. I think it is beautiful. I love it. This is my favorite stuff to teach. I wish I was with you. I'm not. These are not easy. Don't kid yourselves. This is a very, very hard. So if you are doing this and you are struggling, then you need to just do some one-on-one time with me. I'm available all the time. Okay? So I'm going to do another example with you that was on our PowerPoint sheet so you can see me do another and hopefully it will click. Let me just get some more paper here. Try to line it up here. Okay, so this is the next one. Okay, what mass of oxygen gas would be produced from the decomposition of 37.2 grams of lithium chlorate. Okay. Lithium chlorate. All right, so if I was doing this with you, I would probably give you this problem. Right now, we'll work it out together, but I believe on a lot of the questions you are given Yeah, when I look at your worksheet that I'll go through next time, you're always given the formula. You're always given the equation. It's a balanced equation you're given. So that's not too bad. All right, so let's do the balanced equation here. So let's do the equation out. So I've got lithium chlorate, which is LiClO3. So let's pretend they gave you this part. Okay, so lithium chlorate yields to the metal chloride. So here it's, if I told you this in a decomposition, it's the metal chloride plus oxygen. So I'm just going to give you the equation this time because it's a little harder. So let's balance it. Sorry, I'm doing it too fast without you. 1 lithium. I'm going to put a 2 here, and we're going to put a 3 here. Okay? So I've got 6 oxygen, 6 oxygen, 2 lithium, 2 lithium, 2 chloride, 2 chloride, and we're balanced. So let's pretend I gave you that to start this question, because I believe they did. Okay. So what do? I'm going mass to mass again. So let's write down our known. Our known is 37.2 grams of lithium chlorate, which is this, LiClO3. Okay, our unknown, what did it ask us for? What mass, so grams, of oxygen gas, grams of O2, it's wondering, would be produced from the decomposition of 37.2 grams. Okay, this is our start. How do I always start these problems? Always start these problems. I start with my known, and I put it over 1. 37.2 grams of LiClO3 over 1. Good start. I'm trying to go from grams to moles, okay? I'm trying to go from, get rid of this grams of lithium chlorate. Well, I know that the molar mass of a compound in grams from the periodic table is equal to 1 mole of that compound. So I know I'm going to do it this way, just for people who like it like that. I'd like to put grams of lithium chloride on the bottom. How do I know what to put? Well, I need a little scrap paper. I'm just going to do it right here. LiClO3. What's the molar mass of that? Well, let's go find out. We have 1 lithium. We have 1 of them. Let's go find its mass. Lithium right here, 6.94. Chlorine, I have 1 of them. It's 35.45. Oxygen, I have 3 of them. So they're normally 16. What's 16 times 3? 48. And now we got to add them up. Let me find my calculator. Here it is. So let's add them up. 6.94 plus 35.45 plus 48 equals 90.39 grams is the molar mass of LiClO3. Once you know the molar mass, you're allowed to say this. Lithium chloride, I'll start like this. 90.39 grams of lithium ClO3, lithium chloride, is equal to, okay, sorry, I didn't mean to do an arrow, equal to 1 mole of lithium chloride. Okay? This is this first conversion factor. You've done it 100 times before. This is a conversion factor we get to use in a bunk bed. Okay, 90.39. So let's bring it back to this one. The conversion factor we get to use, 90.39 grams of lithium chlorate, is equal to 1 mole of lithium chlorate ClO3. Sorry, ClO3. Okay, so this is a conversion factor I get to use. Awesome. Let's use it. Here it goes. 90.39 grams is equal to 1 mole of LiClO3. Awesome. These grams of lithium chlorate get to disappear. Bye-bye. Okay? I'm left with moles of lithium chloride. Well, that's not what my answer is looking for, my unknown. Okay, I got to keep going. I need another bunk. I'm gonna run out of room. This is the one thing I don't like about these is I run out of space. Because I'm not on a whiteboard. But anyway, so I'm trying to go from moles of lithium chlorate to moles of oxygen. How do I do that? I get to use the balance equation. So I can write another conversion factor here. Maybe that'll help some people see it. So 2 moles of lithium chlorate, ClO3, are equal to 3 moles of O2. This is a conversion factor I get to use. How did I come up with it? Because it's a balanced equation, this is true. You learned that yesterday. So 2 moles of lithium chloride. I'm just going to excuse myself. My kids are arguing, and I think that it's disrupting. So hang on. Excuse me, gentlemen. I'm working. We're done here. All right. This is the trouble with working from home. Anyway, here we go. So this is a conversion factor that we get to do. 2 moles of lithium chlorate, I got this from here, is equal to 3 moles of oxygen. I could have used anybody in here. I could have been talking about lithium chloride, but that didn't ask us in the question. So this is my conversion factor. So who's going on the top? Who's going on the bottom bunk? Well, I'm trying to get rid of moles of lithium chloride. So he's got to go on the bottom. 2 moles, LiClO3. On the top, I've got 3 moles of O2. That's the conversion factor. So I get to cancel out, not the 2, but just the moles of lithium chlorate. And I'm left with moles of oxygen. That's awesome. So I've used this conversion factor and this conversion factor. Now I need to do the last one. I need to get rid of moles of O2 and get to grams. Well, we know how to do that. The molar mass of a compound in grams from the periodic table is equal to 1 mole of that compound. So let's just do a little sheet, another little scrap like this because I'm running out of space. What's the molar mass of O2? Okay, so the molar mass of O2 is, well, oxygen is 16, and there's 2 of them. So it's 32 grams. So I get to say 1 mole of O2 is equal to 32 grams of O2. That's a conversion factor. This we learned that a long time ago. A molar mass in a compound of grams from the periodic table, which we just solved, is equal to 1 mole of that compound. So here's the next conversion factor we get to use. I'm not going to write him on this page because he doesn't really fit. Okay, but I'm going to write them here. I'll leave it like this if you can see them. Can you see it? No. Where am I going to write? Yeah, right here. So 3 moles of O2. So I need moles of O2 on the bottom. So this conversion factor's taught me I get 1 mole of O2 is equal to 32.00 grams of O2. So my moles of O2 get to disappear. And I'm left with grams of O2. That's the unit. I always tell you guys, the unit tells the story. So now I've got grams of O2 left. That's what my unknown was, grams of O2. So I've done it. Now I just have to do the math. So let's bring it back into line here, so hopefully you can see it all. And then I'm going to do the math. All right, let's start. I've got 37.2 times 1, which I don't do, times 3. I always hit equals, times 32 equals, divided by 90.39 equals, divided by 2. So I got 19.75 grams of O2. Okay, and the answer on the sheet over there is 19.8. They rounded up. It's fine. So this is how you do these types of questions. So there's a little summary here on the last slide. It says, summary of important points. You are calculating the mass of 2 different substances. The molar mass is always equal to 1 mole, which we did, right? Right here, 1 mole. The molar mass from the periodic table is always equal to 1 mole. And the only time the number of moles is different than 1 is when you're doing this middle bunk. Okay, this middle bunk comes from the balanced equation. So these were just little reminders. All right, so I think we've covered the slide for day 2. I'm going to stop and then I'm going to do the next video. I'll help you with the worksheet so you can see me do probably 3 more examples of these. Okay, make sure you call me if you need a one-on-one or email me and we'll zip through and I'll help you do the work. Okay, take care.